Hello, so for our video today, we're going to look at an enzyme question, but this one is a little bit different because we're going to use it as an opportunity to talk about standard deviations when we can see the standard deviation or the error bars on the graph. So let's have a little look at the question. So scientists investigated the activity of two different enzymes. We've got GOX and HRP. And they investigated the activity of these enzymes when they are trapped inside cages, which is the bar represented with the letter T on the bar chart, and not trapped, NT, but free in the solution with no cages. So this is actually what we call immobilized enzymes. So the enzymes have been immobilized or trapped inside cages in this example. And here they are not trapped. So they are just normal enzymes free in solution. They have not been immobilized. The graph shows the results. So we've got the relative activity of these enzymes, and the error bars show plus or minus 2 standard deviations, which just means that 95% of the results fell within the error bars marked on the graph. So we can see the error bars here. Now you can call them error bars as they've done in the question, or you can actually just call them standard deviation bars. That's fine as well. So what can you conclude from figure 2, from the graph, about the effect of trapping these enzymes inside cages? Well, the first thing to notice is if you compare the activity of the trapped enzymes to the non-trapped enzymes, we can certainly conclude that trapping these enzymes increases the relative activity, because we can see the relative activity is much higher. It's over 6 when they're trapped, and it's much lower. It's less than 2 when they're not trapped. So trapping the enzymes definitely increases the activity, but this graph has the standard deviations on there, or the error bars on there. So we need to use that information in our answer. So what we can see here is the standard deviations, or the standard deviation bars, or we can call them error bars, do not overlap. Now, what we mean by that is if you look at this error bar, you can see it finishes here. And if you look at this error bar, you can see it finishes here. So there's no overlap between those standard deviations or between those error bars. Now, what does this mean? If there's no overlap in the standard deviations, it means the difference, so in this case, the difference in the relative activity of the enzymes is a significant difference, or we could say the difference is not due to chance. So that's what the standard deviations are telling us. If they do not overlap, it's showing us that it is a significant difference in the activity of these enzymes. If they did overlap, we would be able to say, actually, there is no significant difference between the activity, or the difference in activity is due to chance. But here there's no overlap. So this is what we need to be able to say. The difference is significant. The difference is not due to chance. Just as one final thing before I go, remember what standard deviation is. Standard deviation, if we do a little definition, is the spread of data around the mean. So you should know that. You should know the definition of standard deviation, but you should also know how to interpret the information if you see these standard deviation or error bars on the graph. So I'll repeat it again because I know students struggle with this. If there's no overlap, the difference is significant. If there is overlap, the difference is not significant. I hope you found that useful. Make sure to subscribe to this channel, switch on your notifications. You can get access to all of my videos as I post them. You can probably tell already we're working our way through Year 12 content. So this is perfect for you in Year 13 if you're doing revision, or you in Year 12 if you are currently learning these topics.